Hello, am I audible? Hello.
Yes, sir. Audible.
So it is just
Sir,
beginning of
audible.
several variables. So r to the power n is r cross r equals to set of tuples such that okay, and define inner product summation so and norm x means notation. In my notation, x is square is inner product x that is summation xi square. So mod x is square root of positive square root. Define d, check that it is inner product, is an inner product because all of you know that this is a vector space over R. Define D, this vector space, so minus structure also is there. Check that D is the metric R. So this matrix comes from inner product. Okay. So it is also a Hilbert space. Later we will uh, see what is this. Just this metric comes from for right now. This metric comes from inner product or norms. Okay, now for these are just definitions, nothing else. For a matrix A belongs to L before n, is the set of all R linear map or linear transformation from so that is it is M cross N matrix. Over matrix entities from R. For A, this we define the norm A of A. What is this? Where supremum such that not that Ax belongs to R to the power m. So mod of this also defined this way such that mod x less than or equals to R. So for any x belongs to R to the power n, we have if Ax if x equals to 0, then what happened? Ax mod is always norm A because both side is 0. And that is equal. If x not equals to 0, take y equals to x by mod x. That means then mod y is, what is this? 1. So ay mod is less than norm A because it is supremum by definition. This imply Ax this imply mod x. Okay, so this is a property. Suppose there is a lambda to r such that mod ax is less than lambda mod x for all x belongs to r to the power n. Then what happened? Take if if mod x lesser equals to 1, then I should write less than. So supremum this imply lambda. Just 1 minute. If you have any question, please ask me. Any notation, any question. I should write a recall section here. Recall a normed vector space V, or I should write X. Does it better, because topological space metric spaces are we denoted by is the tuple a norm is the tuple where X is the vector space over R. এখানে আমরা কমপ্লেক্সটা আনছি না, জাস্ট আর এর উপরেই করছি সব। and x to r is a function called norm function zero if and only if x equals to 0. Number 2, norm x. Number 3, less or equals to norm x norm y. Okay, note that if x dot is the norm space, then D, this is x cross x. I want to write here x cross x. It goes to, it is a vector space, so we can talk about minus y forms a metric. X. Okay, so this is this recall. Now we go to some proposition. Today is fast day, so I will do some little easier things. Basically, Rudin and Apostle will be followed. Theorem. If A belongs to L R to the power n, then norm A is finite, always finite. Finite. And A is a, what is A? I should write this map, r to the power n to r to the power m, x goes to ax. This map is a uniform, I should write here not A, L, this is better, is uniformly continuous mapping of r to the power n, uniformly continuous mapping. Just B if A B belongs to sorry, this is M, then norm A plus B is norm A, norm B, and we are just checking that it is actually norm function. That means triangle inequality, these two properties. First is obvious, these two properties we are checking. Just I can put it as a homework also. If A belongs to L R to the power n m and B belongs to L then norm AB, sorry, not AB, because r to the power n to r to the power m a, then r to the power k b. So at first b, then a. B a lesser equals to so these are theorems. So proof of this theorem. I should add a page number 2. Proof. Suppose is the standard basis r to the power n, then x belongs to r to the power n and x equals to x1 xn imply x equals to summation xi ei 1 to n, where what is ei? 0 0 0 1 ith position. So this now norm x less equals no, modulus x, that is norm x less equals to 1, that means summation xi square less equals to 1. This implies modulus xi less than 1 for all I. Okay. Now what is mod ax? That is I should write this xi is scalar. Okay. Now I apply triangle inequality. Now what is AEI? Now apply this. Let lambda equals to or I should take a supremum. So supremum mod x now it is norm A. Now what is AEI? If A is your M cross N matrix, now AEI zero 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 one, that is ith position, that is nothing so what is this? Ith column, right? So this is 1i a m I. So modulus AEI is nothing but summation a j I square then root over j equals to 1 to m. So summation AEI I equals to 1 to n mod is summation square root summation AJI square j equals to 1 to m I equals to 1 to n, that is finite because these are involving only entries of A. Okay. Next, we observe that AX AY lesser equals to just use this this AX mod AX lesser equals to mod a norm A into mod X. So I should write here the what I want to show. Mod AX I should want to write. Okay. So using this mod AX lesser equals to norm A into mod X, what we are getting here? What is this? So it is Lipschitz because it is finite. So this is স্পেলিংটা কি ছিল?
LIPCHITZ.
ওকে ওকে। So it is listed. This imply LA is uniformly continuous. So first one, what is the first statement? Next we have to show this triangle inequality, and this, that means actually this we have defined here. So supremum, it is actual norm. We are checking this. Okay. So for Vx, now this is a norm in r to the power m. So we have this defined a norm, the modulus x root over I equals to 1 to n whole square, that it is your check. Okay. So here we have triangle inequality. Now this is less or equals to mod x. So supremum, what is this? Take lambda equals to, it is finite because by previous. So a plus b x less than lambda x. Now for all x belongs to r to the power n. Now we use this. If mod x is less or equals to lambda x for all x, then then mod norm a is less or equals to lambda. Use this observation. Then what happened here? Norm a plus b less than equals to lambda, that is equals to norm a, norm b. So b is done. C, what is the statement of C? So composition, it talks about composition. A belongs to a is a L, a belongs to L r to the power n to r to the power n, that means A is a linear transformation from r to the power n to r to the power n, and b r to the power m to r to the power k. Then norm ba is less or equals to norm b norm. The same technique, let x belongs to r to the power n. So and ax equals to y, say b ax by, this equals to norm b mod y equals to norm b mod ax, less or equals to norm b norm a mod x for all x r to the power n. Take lambda equals to norm b om a. Then proved. Note that note that if I define D so it is a vector space of dimension mn over R. So norm will define a metric. So what is your AB? AB should go to define a metric. Hence is a
ওটা
metric
আর হবে
space.
না?
Huh?
ডিএল আর এন আর এম থেকে আর হবে না?
Oh, sorry.
Oh, sorry.
Sorry. Defines a metric on hence is a metric space. Because A minus B, I can write it as A minus B plus B minus C. Sorry, I should write A minus C here. So use this norm A plus B lesser equals to norm A plus norm B, so I can find so this is triangle inequality. Triangle inequality. Okay, now we come to the very special case. Number 3. Theorem. Let omega be the set of all invertible linear operators. That means omega is GLN na. And if A belongs to omega, B any set and so I can say that uh, B D mm, at first I write this inequality, then I should B minus A dot A inverse 1 implies B belongs to omega. Hence, omega is an open subset of with this with the metric comes from norm. So what is happening here? If A is belongs to omega implies BD A lambda is subset of omega, where lambda equals to 1 by norm A inverse. Okay, so A যদি একটা যে কোনো পয়েন্ট থাকে তাকে ঘিরে একটা ওপেন বল ওমেগার মধ্যে আছে, ওপেন সাবসেট। The mapping is continuous. I should write this mapping by theta. Is continuous on the subspace topology on omega. Okay. Now proof is quite computational. So our lambda is 1 by inverse let okay. Now let gamma, then gamma into 1 by lambda less than 1, given this relation, more norm b minus a into norm a inverse is less than 1. This imply less than lambda. Okay. Now lambda into norm x, what is this? Lambda is norm a. I can write x by a inverse a x lesser equals to, I can write norm a inverse a x. So lambda into a inverse is 1. So lesser equals to or computational. So this is what is norm a minus b, that is gamma. Okay, this imply so lambda minus gamma is positive. What is x? For x belongs to r to the power n. This is positive because by by star. Okay. So if x not equals to 0, this is positive and this is also positive, so lambda minus gamma not equals to 0 because it is positive. So I should write this on this line as this imply this imply b r to the power n to r to the power n is injective, kernel is 0, right? By diagonality theorem it is bijective. Because same dimension to same dimension, so this line is calculative. So and this line here is some technique also, right? এটা বিউটিফুল টেকনিক, এটা এই লাইনটা থেকে এই লাইনটা so b is, that means b belongs to omega, so bd a lambda is subset of omega, hence omega is open. Okay, next we want to show that is continuous. Start with this. I mark it by star. We start with star. Green star. So we have lambda minus gamma mod take b inverse y, mod b inverse y is lesser equals to b inverse y. Okay, this line, start with this line. So this imply lambda minus gamma y is lesser equals to mod y. So b inverse y, sorry, one by, this is positive, so again using this this line, so norm A is less than equals to lambda if mod ax is less than lambda x. So again using this line, so we can write it, norm b inverse is less than equals to 1 by lambda minus gamma. Okay, now theta a minus theta b, no, norm a inverse minus b inverse, this is our theta map. We can write it as A inverse A minus B inverse, is it correct? What is this? A inverse minus A inverse B inverse, that is identity, minus A inverse B inverse A inverse, that is I should write B minus A, then it is correct. So you can calculate this as A inverse B inverse A inverse B minus A B inverse. So lesser equals to, again we are using norm BA is lesser equals to norm B into norm A. Inverse. Now what is B inverse? That is your lesser equals to lambda minus gamma, and A minus B what is this? Lesser equals to, what is B inverse? 1 by lambda minus gamma. Okay, B minus A is less than, what is that? Lambda. B minus A is less than lambda. And what is A? It is 1 by lambda. A inverse is 1 by lambda. So A inverse is 1 by lambda, and what is B minus A? B minus A is less than, I think, what is B minus A? Oh, B minus A is gamma here. Look at here, B minus A, it is gamma. So I should write here, it is gamma. Okay. Now as A tends to B, this imply gamma tends to 0. If you have any question, please ask me. Otherwise today I will stop here. Okay. These are some basic properties of matrices. Next day we will define differentiation, then inverse function theorem, then implicit function theorem, then integration. It is. If you have any question, please ask me. কারোর কিছু প্রশ্ন আছে জিজ্ঞেস করার? Okay, then today I will stop here.